Hello. So, streaming again. I had a break last week. I think today I need to catch up somehow and do something more impressive, don't I? So, let's see. Um, Idea for today is gonna be to make some kind of level for this penguin game that we were thinking about. So it's gonna be a side scroller game, something like I don't know exactly, but I'm thinking about Mario like movement and some kind of jumping around, maybe avoiding obstacles, climbing on things, and yeah. And some of the enemies that I want to include, I don't know if I can do that today because I never actually coded a side scroller game before. So I'm not sure how it's gonna go, but the enemies for the game, I want to be those tentacle creatures that we built last time. So somehow these I want to be included in the game. But I want to get some kind of basic character movement using the keyboard and yeah, jumping. And I don't have sprites. I don't have animations for this character even, so I'm gonna use some kind of placeholders probably. And in the worst case, I'm gonna draw them myself, but let's see. Yeah, okay. Oh, really? Well, that's impressive. Very good score there in this game, I think. But the game, after we implemented the mechanics and the jumping and the movement and all these things are gonna be, it's gonna be very different. And I think these creatures are also gonna need to move in a very different way. So let's see what we do today. I'm gonna close this and oh yeah, you wanted me to show you this joke where apparently I can't count. So yeah, seems so. But hey, I can't count very well. I can code, so I guess it compensates for something. Okay, so today, what do we have here? I have some basic file to start with. I'm bored of typing very boring HTML every time we start, so this just creates a canvas here in the body. It gives it a background, this bluish color for the background, and removes the margin for the body, and then starts a function called main. This function is empty, so we're gonna build this game from scratch today somehow, I hope. But before that, I need to have some kind of references to this canvas object. So it's called my canvas here. That's the ID. And I need to access it somehow. So let's say canvas, and I got some comment a while ago that it's a good idea to keep a reference for the context. The context is that thing that has all the drawing methods from the canvas. So we use it to draw everything, and it's good to have it as a reference, but we also need to initialize this canvas and make it stretch the full screen. So let's do that here. Stretching the width and the height. Right. And now we get an error because I didn't get a reference to this yet. I'm doing everything backwards today, it seems. Okay, Now the canvas stretches the full screen. Oh, okay. Well, let's see. If you don't make sprites, then I'm gonna have to make at some point, but I'm gonna work with squares and rectangles meanwhile, so I can do stuff. Take your time, but if you want more screen time for your sprites, then you better send me something. Okay, now we have our canvas stretching there, but we need to make a character. So let's say that our character, let's give it, let's make it a class. Let's call it Penguin, because we will have many other characters in this game. So maybe it's a good idea to name these properly already now, even though this is gonna have a lot of refactoring later on, so it doesn't really matter now. We are just playing around trying to get the game mechanics and the movement somehow in a decent way. Okay, so this penguin is gonna have a constructor. We are gonna define it somewhere, and we're gonna give it a location where we want it first to appear in. And the penguin is going to store this location inside its own attribute. So it will always know this location where it was constructed. We will do something like maybe penguin, new penguin in the center of the canvas. Let's put it in the center of the canvas for now. So X is going to be canvas width divided by 2, and Y is going to be canvas height divided by 2. I think that's nice. Yeah. The penguins follow Santa. Yeah, it will require a lot of sprites. So you mean you want to control Santa and then he's followed by some penguins walking behind him and they don't want to go away. He tries to shoot them around or whatever. And then at some point when he gets his sled and magical powers again and penguins start to fly, then maybe he thinks they are actually useful. Could this be a storyline? Oh, salutare, Dark Scorpion. Yeah. So I think those are good ideas. Yeah, cool. Write them down, put them in the documentation. So anyway, this penguin here, adding it to the center of the canvas, and maybe we want to draw it using the context of the canvas, so the methods from there. The penguin object is also going to need this draw method on some context, and there, well, let's just make it a rectangle for now. So make the sprites. I'm going to try to draw a rectangle. So let's say begin path, and then let's make it green. I think, okay, I prefer to use this rect method, so it starts at this location X, this location Y, and then it goes, oh, this penguin doesn't have a size. I'm thinking about this well, the basic Super Mario Brothers side scrollers and how they are implemented. And everything seems to be made of these blocks, and I'm pretty sure that many of the hitboxes there are actually squares or rectangles or something like that. I haven't made things like this before, but let's see what happens. I'm gonna decide a fixed size for these blocks. Maybe something like 10% of the canvas height. It kind of looks like I could fit here 10 of these rectangles, 10 of these squares vertically. So maybe we try something like that, but let's see how it goes. Okay. So block size equal to 10%. I just write here 0.1. And I'm going to say here, to draw it on the context, is block size multiplied by context dot canvas dot height. So let's see if this makes sense. So our rectangle will start at whatever location the penguin is. This one is going to be in the center of the screen. And then its size is going to be this parameter. And I need to say here the width and the height for this rectangle. So it's going to be a square, for now at least. And then I want to say that I want to fill this shape. So, okay. So something works, at least some drawing is happening here. So this is going to be our penguin, right? Not just a square, but for now this is it. And one problem is that this is the center of the screen here, but my character looks like it's hanging from the corner there. I would actually like this center point of the character to be here, this origin to be somewhere in the bottom center part of the object. So I'm just going to draw this rectangle not at X and Y. I'm going to draw it up by minus size, so like that, and to the left I want it to move by half. That way I have a better origin for this object. So let's see if we can also draw this this origin somehow. So I'm gonna say arc, a small circle. So I'm gonna use this arc method to do that, and I'm going to make it at this location X and this location Y with a radius of, let's say, size 20% of this size or 10% of this size. And then yeah, this arc method also needs two more parameters here, 0 and pi, 2 pi. This makes the full circle. So the circle starts at 0 degrees and ends at 360 degrees or 2 pi radians, another measure for degrees. And then let's fill this one also, but let's give it a red fill style. So, okay, I did something wrong. Here I wanted this half the size to the left. So now our character origin, its center point, it's at the bottom and at the middle of the character. So this is going to be a little easier when we do things like make the character not fall through the ground when gravity comes on, or things like that. So I just prefer it to be there. Of course, you can always think about where is the center relative to that, but I prefer to keep it there somewhere. Uh-huh. Yeah, okay. I will try to write it, but I may forget it by the time this ends, and I don't want to write now things during the stream. It's not fun. So I focus on game development. Okay, so this is our character. Let's make also our stage. So I'm gonna make those kind of block objects that are forming the ground and different platforms that the character can jump on. I think that I'm gonna just copy this class, and I'm gonna say block here. Again, it's gonna have a constructor, I think. And let's give it, let's mark its origin also somehow, but with a different color, maybe blue here. And let's make these yellow so that we differentiate what is the character and what are these blocks that the character is going to move on. And here I'm going to say, I don't want these blocks to have this kind of bottom center origin point. This may be a stupid idea, or okay. Let's move all the origins actually to be in the middle so that we have easier math to code in when we do the collision detection. So let's see how this goes. Okay, so now we have blocks and the penguin character there. Let's generate some blocks. I'm gonna make a function here, generate blocks, and then store them in this in a global variable here. Hello, Darius. Master Skier is done for this winter. It's the snow is melting outside, so yeah, next winter he's back. So now these blocks, this is going to be an array of these block objects. We want to draw them also on the context. So let's go through them. I'm sorry, but next year, right? It's there is always a next winter. Now, yeah, so now we're drawing them, but we don't have this function for generating the blocks. So where do we put them? That's the question of the day. So let's say that we put many of them on the bottom in one row. Yeah. And okay, I don't like this block. I think that I will need to do this a little bit differently. I'm always calculating the size using this percent value actually. So let's change this a little bit and actually calculate the block size in pixels. That is going to be defined here as the height of the canvas multiplied by this percent. And now we can use this block size everywhere instead of this size. And I don't need to recompute this size in all places where I'm using it. So yeah, here either. Okay, and now I have this block size available. So let's try to draw this ground where the player is going to walk somehow. I'm going to say, let's try to generate first 5 blocks. And put them somewhere down. So, okay, I think it's important to pass the context here also because it has information about the size of the window. Or not really. We don't need that because this block size controls now the size of the window. Remember, it's made out of 10 different out of 10 blocks basically. So let's try to draw these blocks to generate these blocks at different locations relative to this block size. So I'm going to say empty array here, and I'm going to push into this a new block. A new block, and the location of this new block is going to be let's put it at 0x for now, and y is going to be I multiplied by this block size. So this actually should draw us a vertical line of blocks. Yeah, let's just test and see what we are doing and then modify. But I need to return whatever array I'm generating here. So that. Wow. Okay, so some blocks are appearing there on the left, these yellow things. I think I like them there because maybe we want to have a start of the level and not allow the penguin to go backwards. So let's make this wall have actually 10 blocks, and now it's going down. But I want them, you can see, we don't see the full block here. So they need an offset by half a block to the right and half a block to the bottom. So let's make this offset here and add it to the X and also to the Y. So now we have those 10 blocks that are forming the side of the screen. And let's make also the ground now. So the ground, let's make 6 blocks in the beginning. So for those, we need to change this X value, not the Y. The Y value is going to be something like maybe 9 times block size plus offset. And the X is going to depend on this Y. So same as before actually here. But our Y is fixed somewhere at the bottom of the screen. So now when I'm adding this piece of code, I'm starting to make the floor here. And let's be creative a little bit. Maybe we can make some small platform or something for testing jumps and things like that. So let's make a little bit an experiment here. And later we can actually serialize this as JSON, or maybe we figure out some other way of storing the level once we are happy with how the level is configured, we store it in some file and then just load it from there. So all this code is going to disappear from our main functionality. It's here just for playing around today and testing new things. So let's make it maybe a little bit higher up, and yeah, actually we should continue this. So maybe starting at 7 and going until 9. Now we get this platform here. I'm gonna move it a little bit lower, so maybe like that. Great. And let's have our character start somewhere here. More to the left. So now we are generating our character somewhere here. Canvas width divided by 2, canvas height divided by 2. Let's just put it, because now we have this block size value there. Let's just put it at block size times 2 and block size times 7. Okay, it doesn't have this offset that we have for the others, but it won't matter. I think this is just fine. Let's just make it here times 3, so it starts somehow at equal distance from the sides. I'm a perfectionist like that. Okay, great. So we have a little bit of a beginning here, and let's make also a few more ground parts that will continue from here to the right, so that it gives the impression that this game is actually going somewhere, not just yeah, not just ending there all of a sudden. So here we continue now from, let's say, 10 until 16 or so. And now we get a little bit more things there. And if we really want to get crazy and try to give our character more abilities, we can put different platforms here and maybe try implementing some double jumps or weird things like that. But let's see. For now, I think that I have a lot of things to worry about, and we are just drawing squares at the moment. So, character needs to fall, and for that, character needs some kind of gravity. Last time, when I implemented those creatures, those characters there, let's see, do I still have... Oh, I don't have it open anymore. But those octopus creatures, I used a method for the physics there, and it's not something that I think is very much used in these side-scroller type of games. But I'm gonna try it, because I'm thinking if it's possible to unify the physics inside the whole game. So basically, I'm gonna re-implement that method that I used in that tentacle creature, that octopus thing that I showed in the beginning of the stream today. And see if I can apply the same physics, the same mechanics to this character that we are building. So let's see. If it works, then that's great. But I did check some tutorials about these side-scroller games just a few hours ago, and people use much more simpler things than this. But let's see, maybe we end up with some unique kind of movement, like control for our character here. So the gravity is going to be a force that applies zero force horizontally, and then some kind of force vertically. I'm just gonna put a small value here like this. And I'm going to say that this gravity will start to affect our penguin somehow. I'm not exactly sure how to implement this now, but let's see. And then I want to also add keyboard control to the penguin. So let's begin with how this gravity is going to affect, and go to our penguin class and say here update its location. And then maybe here we're gonna have a force. That could be one way of doing this. Yeah, or I can use this gravity as a global variable. So let's see how this is going to go. But I'm going to try to implement the same method from the monsters that we created in the last episode. So for that we did, we first calculated the vector here. Yeah, we basically had already some utility functions there for adding, subtracting. I think that I actually need to take those. Let me see where those are. Or I could actually include the Octopus file. Let's see how that one looks like, because I added the utility functions to the Octopus, this monster character from last time. So if I were to, yeah, so this is now Octopus code from last time, and somewhere here, yeah, there were these utility functions for adding, subtracting, normalizing, scaling of vectors, so linear algebra. And in our particle class, we had here some useful things that I'm gonna reuse now, like, yeah, I think it's faster this way. So I'm gonna get the velocity, how the speed of this particle was moving. So this updating of this location, I'm going to take it from there. So it's getting the vector from the current location of this penguin and the old location of this penguin. So let's add here also an old location and initialize it in the same way. So velocity just means the vector from the old location to the current location. Now I'm gonna comment some things here because I want to explain how this code works again. And I think that I have a lot of things that I don't need at the moment here. But basically, it's calculating a new location based on this velocity by adding the value to that, and then adding the gravity to this. Then updating the old location to the current one, and the new location becomes the current location here. So relatively easy code, but let's see if it will work here. Yeah, and if I refresh now, then nothing happens because I need to update this penguin's location somewhere, and I actually need to animate everything. So this is something we didn't do yet. We are just drawing this green rectangle here, which is going to be our penguin character, and also these blocks here. But these should update on every frame, and this should be an animation, and gravity and things like that are going to take effect. So I'm going to start the animation here, and say that this function is going to call request animation frame. So this will try to give me 60 frames per second, and every time it updates, it's going to call the same function again and again. So this is kind of like a like a recursive call, but with a small timeout there. And then here I want to update the scene, for example. Now, this scene updating function the scene updating function is going to take our penguin and call this update method so that it so that it applies the gravity, this gravity value to the penguin, and then it's going to draw the penguin. So actually, I don't need to draw anything there because it's going to be drawn inside the animate function on every frame. And I also need to draw the blocks, otherwise it's just a penguin there all the time. So I generate the blocks here, but then they need to be drawn on every frame. Okay, not what I expected, but now this green block that is our character is going down, and it's actually accelerating if you pay attention. So if I go back here and make our penguin maybe start off here, you can see that it's going faster and faster. So it's not going down at a constant rate. It's going down a little faster because if we go here to the code, we see that we get the current velocity vector from the current location to the old location. So let me open PowerPoint a little bit. Basically, this is our character there, and at the beginning it's pretty much not moving, but at some point it's gonna move like this. And when it's gonna move like that, this, what we have here, is actually going to be the old location. So this here is going to be the old location, and this is going to be the current location. And when you do this kind of subtraction here, this just gives you the velocity vector that you want to add to the new current location, which we are doing here. So this means that we are going to take the current location here, and this is the velocity vector that we calculated based on the old location. This is going to be now added to create a new future location going here. So that's what's happening in the code that I copied from this Octopus monster there. And in addition to this, we also add to the new location a gravity. So if I go back here, that means that this gravity is going to be an extra force, maybe a smaller force like this. And the future location is going to take both of these into account. So if you look at what's happening here, the block is going to move more on each frame compared to the previous amount that the block has moved. So yeah, and yes, it's supposed to okay, I'm blocking the screen here, but I think you get the point. Yes, it's supposed to clear the blocks that are previously drawn. It's actually supposed to delete. It's easiest to just delete everything and then redraw everything, because we are already redrawing everything in this update scene function here. So let's begin our update by clear rect. So this is going to delete everything in the scene if we begin at 0, 0, top left corner, and end at that. So now the character goes down and it goes down and it goes down faster and faster. So this is somehow okay. I think it moves much slower than what I would expect character in this kind of fast-paced game to move, but it's something that we have to work with. And the next thing that we have to do is implement now collisions. So how do we implement collisions is, wow, I'm getting some weird error here. Hope nothing important broke, because my PC said that fatal error or whatever, and then I just clicked OK and nothing happened. So let me know if you can't hear me, which is a stupid question to ask because you can't hear me saying this if you can't hear me. But yeah, let me know if something's up. Great, so now collision detection. There will be many things. Okay, good. There will be many things that we need to do to optimize this and speed up this, but what I'm going to do now is try to see if our character collides with any of these boxes here. So if I'm going to bring back the PowerPoint drawings, let's just move these things a bit to the side. I want to somehow detect collision here. And if this is going to be our character, here, and we collide with the ground, like if this happens, I think that what we need to tell this character is that it needs to move back up. Yeah, to move back up to before the character collided with the ground. So if the character falls like this and something like this happens, then immediately, before even drawing it, it needs to move back up to before the character did that, if that makes any sense. So let's see how this goes. It's not going to be very easy for me because I never tried this before, but yeah. And how do we detect this collision? This is another question. So we have the origin of these shapes like this, and we have a distance between these two shapes, a vertical distance and a horizontal distance. So if the vertical distance between these two shapes, basically this distance here, if this one is more than our block size, so if this distance here is, no, it's less than the block size, it means that we have a collision. So this is now the block size for reference here on the left, and the distance here with red. Well, you can tell what the block size is. So if this one is less than the other one, then we are going to have a collision. let's call this dy. And I think that if we have the same, no, if this happens, we don't have a collision because this is not enough. We could have this situation here. So this dy is less than the block size and we don't have a collision. We also need to calculate this, this dx. So yeah, something like this. Yeah, so we also need to calculate something like this dx value. And that one also has to have some kind of property there. So dx needs to be also, I think, less than block size. So both of these need to happen for it to be a collision. In this case, dy is less than the block size, but dx is not. So there is not a collision between these two objects now. Yeah, I think this is something that we need to work with next. So let's see. I'm going to say here in the update scene, so here we are updating the penguin location and okay, drawing the penguin, drawing the blocks. Let's make another function here for draw scene, because otherwise this one with the update is going to become very, very long. And say here that in the draw scene, we are just going to do the drawing side of things, drawing the blocks, drawing the penguins. But here, let's handle collisions now. So I'm going to go through all the blocks. And try to test collision between each blocks and the penguin. So if penguin collides, with this box, so this blocks of I, then do something. But okay, let's make the penguin box a different color. So is colliding equals to true, and otherwise the is colliding remains false. So if it collides with any of the blocks, is colliding is true. And let's make also this block tell us if it's colliding or not, so that we get some kind of visual indication that this is indeed happening. Otherwise, this block is going to not collide. So a block is not colliding, but if it collides, the block is colliding, if this makes sense to you. Yeah, I heard that you made sprites, but we are not there yet. So I will check them after we get this functionality down, and it may take some time. I hope half an hour is enough, but no idea what's happening now. So it's kind of uncharted territory for me, this type of game. Okay, and to display these differently, I'm going to go in the penguin and say here is colliding equal to false, and the block is colliding equal to false. But if this is colliding, then the fill style, let's set it to red. So now our block is going to say that it's going to appear red if it is colliding, and Same for our penguin character. Let's make it transparent red. Because I want to see the intersection between the collision boxes. This could be useful later on. Okay. Okay. Where were we? So setting the is colliding attribute to true only when the penguin is colliding with a block. But we don't have this function implemented. So what did we say in the PowerPoint here? That the dx and the dy must be less than the block size. So collides object1, object2, and if object1 dot location dot x minus object2 dot location dot x is less than block size. So this actually needs to be absolute value, because we may get negative values here if one object is more to the left and the other one is on the right, or if we turn this around and one object is on the right and the other one on the left, then we are going to get a negative value. And even if they're far away, this is going to be negative value, definitely less than this block size. So I need an absolute value here. And I need to do this check also for the vertical component, so this y component. And if both of these are happening, I just return this true. Otherwise, I return false. So basically, that's it. If this works. So I don't know. Nope. So I was hoping that I get here some red colored blocks, but I'm not. So something here doesn't work. And to find out what doesn't work, we need to debug. So I'm going to go here to my collides function. And okay. Wow, this is happening way too frequently. I need to disable this breakpoint. Okay, values seem to be updating okay, but okay, so something actually does happen because this breakpoint is triggered here. So it stopped. The movement stopped because of this breakpoint being triggered here. So this collides actually works, but is colliding is not set to true. This is strange. So the color here doesn't indicate the collision happens. So what gives? Okay, let's try this again and now go step by step through these. So the penguin is colliding now. It's set to true. Okay, I think we can remove this one from here. and then move into the draw scene function. And now the penguin is colliding. So what happens in the draw? We go inside this function, and this is colliding. So I don't know why it's not green. Why it's still green. Let's see. It changes the fill style. What? It didn't change the fill style. How is this possible? This is very strange. So, okay, let's remove some breakpoints here. And when the collision happens, so this fill style is a green value from here, then it's colliding. And then I just moved the next line and fill style is still the green value earlier. So, oh, I have a typo here. It should be RGBA. So it didn't recognize this, and probably it just went with the previous. Yeah, my bad. Okay, so you can kind of see what's happening now. When the character goes down and touches those blocks, it still goes through the blocks, but we identified that there is some kind of collision happening there, intersection between those. And it's falling in the middle of two blocks, so actually both of those blocks are telling that we need to move back where we came from. So if you remember this drawing here, well, let's try to make a new one. So if we have some kind of collision like this, I think that the idea is going to be that we are going to move our character back up to before we had the collision. So this goes, probably this should go also in horizontal axis, like if we are here like this, like if the character is jumping and then it intersects this block, it shouldn't pass through the block. So it should be moved to the side somehow. I'm not exactly sure how this is going to go. Let's see. I think the physics might be difficult if we just invent it here, but something is going to happen. So yeah, so now that we detect the collision, we need to also handle the collision. So that's what we are going to do now. And basically, if the penguin collides like this, it's not good. We need to find a way to move it so that it doesn't collide anymore. So this collision vector would be important to have here. Let's try to return this collision vector. So basically, the differences of these of the current location of one object and the other, but relative to the block size somehow. So no, this is tough. Okay, we need to actually know where the object came from, where this green object came from. So if it came from something like this, like if it came from the bottom, from this direction, let's make an arrow here. if it came like this, and it's intersecting now, we detect that it's intersecting, it should actually display its last location here. So we need to move it backwards. Wow, this is not easy. So we need to move it backwards, basically the way it came, a little bit. So this is what we need to calculate now, this vector going backwards just enough so that it doesn't intersect anymore with the object. So how big is this movement going to be? I think that, wow, this is tough. Okay, and I'm not sharing the PowerPoint screen, so great. So basically here, I was showing that if the object comes from here and then intersects, then it should be moved. Or maybe it doesn't need to move like this. Maybe we just need to update its y component according to this intersection here. So this value for the intersection, just move it down a little bit. But then we also have the collision from the side. This is tough. Let's see. I'm gonna try something, but who knows what we get. So if we get this collision, I'm gonna return here food line. No. I think it's already in the game, isn't it? You can hear me saying that anytime you want. Okay. How did the food line go? Can you type it? I don't remember how it went. Tell me how the food line went. So Ville was talking about food. Was that good? Sounded very much like what the game is, didn't it? Yes. Okay, sprites later. First collision. This is difficult. I don't know how to do it. I don't know how to do it, and I don't want to spend time somehow implementing it. Like trial and error. So if it collides, the penguin is colliding, but let's make its location also. Yeah, let's try it like this and see what we get. I just don't know. The y is going to be equal to the y location of the block plus the block size. But this is if the character is coming from the bottom I think. Like if it jumps and it hits the block. We also need the opposite. If the character is coming from the top, it needs to land on the block. Yeah, okay, so if okay, maybe this is not so hard. So if the penguin state is equal to falling, then we handle the collision in a certain way. Okay, this may be a need for a switch case instead of an if else, but let's just do this for now. So if it's falling, we handle it in a certain way. Otherwise, if it's jumping, yeah, maybe like that. Otherwise, if it's jumping, then this needs to happen. We are basically checking if the penguin hits with its head this kind of block. Otherwise, penguin Y location is going to be the Y of the block minus the block size, so that it doesn't go through the block. Let's say. And because of this location, old location thing that is used in my physics model, so here we have this old location and we are constantly calculating the velocity here. This really helps when you have multiple forces impacting the object, and we needed it for this monster character. So when this happens, we actually need to set also, I think, the old location. Y to the same Y of the location. Otherwise, we probably get some weird behavior. Let's see. I'm not gonna do this yet, but I predict that I need to do this. So let's see what happens now. And we don't have this state actually implemented. So because our penguin starts off falling in the beginning, I'm going to say this state is equal to falling. And now, wow, okay, this worked surprisingly well. We still don't have character movement, but yeah, I'm going to make really nice hitboxes, so they won't be these boring squares there. But I need to learn how to make these type of games. And I'm gonna start with these simple objects here. Okay, great. Now that we got this part working, and I don't think this is a great thing what we are doing now, so I think that this code will need to be remade, but we have something. Let's implement character controls. So I'm going to say in the main function here, document add event listener key down, maybe on key down, and key up on key up. So let's see what happens in this on key down. I'm going to log this event information. I don't remember how to implement keyboard handling, but I think it's easy to debug. And same here for the key up. So now if I refresh this page and I go to the console and I'm pressing W, nothing happens. Okay. Maybe this is not capital here. Yeah. Okay. So I'm getting here the event information, and some of this event contains this key object, key attribute. What happens with the, oh no, not that, with the up arrow? So we also have this arrow up, code here, arrow up, key here. So I'm thinking about implementing this. I think I'm gonna go with WSAD keys for the control. So let's do it like this. And this W here is lowercase w, but if caps lock is on, oh great, then it's uppercase W. So this is kind of, okay, but this code seems to be the same. So key W is actually the same. So I'm going to use this code here. Hopefully this is the right way to do things. If somebody knows better, then do let me know. So if it's the key W, then okay, but W, what is it gonna do? Maybe it's gonna jump. So do jump. But I just want him to move left and right first. So let's do those. S, maybe it's going to crouch or something like that. Let's see. A. So this is gonna be go left. So I'm just gonna try penguin. I don't know how this physics is gonna look like really. It's just trying something. So penguin location dot x minus equals, let's use this block size as a unit value. So let's move it to the left of the block size. I mean, by a fraction of this block size to the left. And if the key D is pressed, then it's going to move by a fraction of this block size to the right. So no, I don't like this. It's not good because, yeah, it's not good because if I press a key here, so now I'm going to press D and hold D. So see what happens here in the console. If you were careful watching, then this appears, this first log appears, but then there is some time before a lot of them appear quickly. So somehow the keyboard doesn't want to let you to press multiple times the key at once. So we need some different logic for how to handle this. Let's implement this by move vector. So we're gonna have a movement vector here with 0, 0 by default. So this is not gonna affect the character in any way. But if the key A is pressed, then this movement vector is going to be horizontally. Yeah, horizontally, this is going to be minus the block size. times this 0.1, and the y component, it's just going to be 0. So when you press left, you only move it to the left. And I'm not going to do this here. I'm actually going to move the penguin in its own update function here. I will update it by this movement vector as well as the gravity. So now there are two forces affecting that. Maybe a good idea to add as arguments here the forces. But for now, let's see if this works. So otherwise, if otherwise, if on key up, the movement vector is going to reset to 0, 0. So if up key is pressed, then it doesn't move anymore. Let's see what happens. Okay, falling. Wow. Wow. This is way too much strength here. Too much force. So, and we have this physics system. This is actually called Verlet integration, and it adds always these forces, and acceleration is always it's fixed because we always accelerate by this movement vector. So this could be actually called acceleration vector here, but there is no friction or anything like that. So if I hold the key down, it's just gonna go forward and forward like forever. We need to figure out some way of handling this. But I lowered the value for now, so let's see. Okay. It's sliding like on ice. This needs some kind of dampening, but something works. Okay. Huh. Yeah, interesting. This dampening should happen to everything. So any force that we add to it, the player is going to have some kind of friction with the ground. And I think that we could consider this as friction here. I'm stealing the friction value that we used to make the octopus creatures. Yeah, maybe it works here also. Okay, so now if I press left, it okay. Collision with this wall works horribly, but okay, this friction needs to be higher here than for the monster characters, maybe 4. Oh, but now the character has also friction with the air, and basically that means that that object reaches terminal velocity quite quickly, I think. I could make the gravity a little stronger. Let's see. Yeah, this is interesting. So now if I just tap, the object, the character moves a little bit. It's still too much for my taste, I think. Maybe higher friction here. Yeah, and the character also speeds up the longer you press this thing. Okay, see you. Remember to check at the end what we have here, because I'm gonna link this thing there. And maybe I'm gonna get to the sprites also, or maybe not, but let's see. Anyway, see you. Yeah, okay. Something weird happens there, but okay. Let's see. So this do jump. I think that in this is colliding. So if the object is falling, okay, difficult. I don't know. Maybe I can take the y component of this move vector and say here that I want to give it an upward force. I'm not really sure what I'm doing, but let's see. Okay, it is jumping, but okay, and if I hold the W key, then yeah, if I hold the W key, then it just flies. I can basically make it fly like this, and I could even move it around in some weird way. Interesting, but not what I want to implement here. So this should do the jump only if the object is on the ground somehow. So, okay, maybe these penguin states need to be decided somehow. So maybe we have grounded, falling, jumping, something like this. So if the object is falling and the collision is detected, then maybe something like this could happen. I'm not sure. Yeah, but I also need to do this check if the penguin is grounded here, because otherwise it's going to fall through the ground. Wow, this logic is very bad. I think I need to refactor this next time. But let's see. So if the penguin is falling or if it's grounded, then I need to move it back up. Okay, and here, if penguin, if the state is grounded for the penguin here, I'm going to then do this change to the y movement vector. So I can only jump if I'm touching the ground, basically. Wow, error. Yeah, I forgot the double equals here. Okay. Nope, something doesn't work. This was supposed to be over here. Okay, and if I'm jumping, then penguin's state should change to falling again because he's in the air, so basically gravity effects. So let's see. This is strange. I shouldn't be able to fly like this. Hmm. Yeah, no, this is very complicated. So this movement vector now is okay. So I'm doing the jump. If the state is grounded, the movement vector becomes like this, but I'm not releasing the W key. Hmm. Okay, what is happening here? Okay, well, something is happening, but why, when I press just very briefly like this, it jumps only a little bit, but if I hold, it jumps for longer, even though yeah, okay, because it takes some time for the key to affect the second time. Okay, dirty things need to do here, but I'm going to say, yeah, not good. I don't like this. I'm going to stop. I'm going to reset this movement vector y component to 0 after 100 milliseconds. So let's see what I'm getting here. Okay, now I'm getting what I want, but I suspect a lot of problems here. And the size, the force of the jump, I want it higher. So let's see what happens with 10% of the block size. Wow. Okay, way too much. And actually, by mistake, I implemented also jumping higher and jumping lower, depending how quickly I release the jump button, because it takes here 100 milliseconds until this is reset. So if I release this, then it's going to go here and immediately reset it. But if I am in this function longer, like if it's pressed for a longer time, then it has a chance to apply more more on this jump. So actually I have somehow this no, I don't like it. It's inconsistent. Somehow this timeout doesn't always fire after 100 milliseconds. It's bad. Yeah, I don't like it. Hmm. Let's try 300 milliseconds. Yeah, going through the roof. Way too high up. Kind of inconsistent. No, I don't like it. No, it's very bad. Okay, back to the drawing board. Uh, hmm. So updating the scene here. Updating the penguins, and if this movement vector dot y is greater than 0, I reset it. Dirty fix. But is it now consistent? So no. If it's different than 0, becomes 0. Yeah, okay, something happens, but now this value is too small again. Let's put it bigger. Okay, way too big. Too small. Okay, this is something now. So movement left and right, and can I actually jump on the platform now? Would it work? Okay, so I can get on the platform, but I still have very many bugs with this collision detection, like this. So horizontal collision detection is still a big issue, and I think it happens also if yeah, okay. So this is one issue. And another issue is that I can seemingly jump after falling here in the hole. Okay. Hmm. If it doesn't collide, then it's falling, isn't it? Yeah. Okay. And I really think I need to do this here so that that weird bug doesn't happen on the side of the wall. Okay, it still happens, but it doesn't shoot it into orbit. And here it snaps it to the top somehow. Yeah, this is not something that I really love at the moment, but yeah, the horizontal movement needs to happen also. Okay. I like the feel of it. I don't know. What do you guys think? I'm gonna try to put this, let me put this on the web and you can also try it and let me know what you think. Okay. Mm, hmm, just a second. Okay. This is the link. I'm pasting it in the chat. So there are some bugs there, but something seems to be working. Like at least I can jump on that platform and well, this issue is there. Now if I fall from this platform, I can't jump midair anymore. So that's pretty neat. And hmm, yeah, but okay. I can change directions mid-air, which is nice. I think many games have this thing that you can change the direction in mid-air. I don't like this snapping and going back up, so this is something that needs fixing. Let's try to also make a box here and see if I can hit this box if I try to jump under it. So yeah, let me see if I can do that. Yeah. Here where I'm generating the boxes, I'm gonna put two boxes. Well, okay. Okay, one box is there. So what happens if I jump? If I jump, I get teleported. Um, teleported through the box. So not good. Not good. Yeah, some weird behavior here. Okay. My states here. So I have a falling state, then a grounded state, a jumping state. So this is actually something where the I'm never in the jumping state. So when I'm grounded, I actually should be in the jumping state for a while, at least. So, okay. Okay, it's grounded. It's falling or grounded, then this is not correct here at all. Okay. Okay, so I pressed the jumping state, the jumping button, and then what? It went to the jumping state, and then how did it end up at the falling state and then the grounded state? Because it should be here. It's never there. Nope. Jump is pressed, but then this jumping state changes somewhere. Oh, here it changes to falling if it's not colliding with anything. Ah, no, not good. Okay. Okay, so it hits that block, but then it needs to be falling. So if it's jumping, it hits the block, and then it needs to be falling. This logic is very hard if you have never done it before, and I haven't. So let's see. So if it hits the block, then it starts falling immediately. But also if it's jumping, it starts to fall after some time. So now the jump takes some time, like okay, a little over a second. So maybe when jumping here, I'm going to say penguin state is equal to falling after some time. maybe 400 milliseconds or something like this, but only if the state is jumping. So state might change in many ways during the jump. So maybe this is important to have here. Yeah. And let's remove these console logs from there. Okay, now I'm not falling through the ground anymore. And here I'm hitting that block. Okay, this is good. So I have now collisions handled with the bottom side and the top side, but I still have these problems like teleporting on the top somehow. I don't think this should happen. This should just fall down. So if yeah, this is gonna need more thinking how to fix. No solution on coming, like no easy solution coming right up. Kind of like the movement, but left and right, this is something that needs fixing. So this left and right, well, if grounded and some collision happens horizontally, then this is also one thing. Yeah, no. I think I need to figure out how other people do this. So it's too tough to come up with this, and I kind of like it, but there are some issues that not so obvious how to change. So now I'm jumping, and I expect it to stop on the side of that block there. But it's snapping to the top and to the bottom because its object is either falling or jumping, and we have this two state here. If the object is moving from the side and intersecting that, yeah, it's problematic. Okay, I think that I'm gonna stop today and continue next time after I study this a little bit. But something here kind of working. And next time I think I can wrap up this movement here and also add some graphics that you guys made. So let's polish this next time. Wow, what happened there? Yeah. Okay, so see you guys.